Hello, friends. How are y'all doing? She is late. I am not late. I am, in fact, 1 minute early. You should be very proud of me. I am not late. Wait, I gotta mute myself. Late is 5 minutes. I agree. I think it's called fashionably late is fine. But yes, as you can see, I am not alone today. I hope you can see that, at least. I am not alone today. Thank you all so much for joining, for tuning in from wherever. Good night, good morning, good evening from US, Owensboro, KY, Kentucky, right? KY is KY Kentucky. I think it's Kentucky. Central Time. Hello. So should be 7 p.m. for you. Appropriate topic for me since that's what I'm doing currently, going through all my articles and videos to select the most useful LLMs. Then this is going to be an extremely helpful live stream for you, especially the guest that we have today, which I shall now introduce. So this is Louis Peters. And he does have a co-founder who's also called Louis. And I got that confused several times. But it's Louis Peters and it's Louis Francois, right? So two Louis co-founders. And I am really, really excited to have him on board today. So I'm going to give you like a brief introduction. So as you can see on his shirt, he is from Towards AI and he is the CEO of Towards AI. He's based in the UK, but I believe you're in Australia right now, right?
Yeah, currently I'm in Sydney, but generally based in the UK.
Generally based in the UK, yes. Okay, so background-wise, really interesting background. So started out master's in physics at Imperial College London. He literally did space stuff. So you were doing spacecraft data orbiting. Final project is analyzing Cassini spacecraft data orbiting Saturn. So you were literally a space. Is it called astrophysicist? Is that astrophysicist?
Space physics is more spacecraft data, whereas astrophysics is more telescopes and things, but they're quite a lot of overlap.
I see, I see. And then you pivoted into investment research 5 years at JP Morgan. He was VP and led analysts across several sectors across Europe. So he worked in finance for a while, also to prepare for his own venture, which he did 7 years ago to full-time focus on learning AI. So this is way before, the AI boom. Everybody thought it was like super cool and things like that, right? So you definitely saw all of that happening, startup projects, and he also advises many AI startups. So, guys, this is your person to ask if you're interested in AI startups, the cutting edge of AI education. He also advised a personalized drug dosing platform called Vazinta. Is that how you pronounce it? Vazinta? Yeah. So if anybody like is looking for a startup advice or what to do, this is your guy to ask. Very, very deeply knowledgeable. And for the past 5 years, he's been focused on making AI more accessible as the CEO and co-founder at Towards AI. And Towards AI is a global remote company, and his co-founder is in Canada, who's also the guy who's also called Louis. And they also have people in the US, India, Italy, and Germany. So I actually initially met other Louis Francois, at an NVIDIA event and like some other events previously. So I met him there. And yeah, and then we got connected. I realized all the things that Towards AI was doing, and honestly, they are amazing in terms of AI education. They have lots of courses as well, which I will share with you guys as we go further along into the live stream. So if anybody is interested in just learning about AI, like this is your go-to person, and especially like AI startups, businesses. He's also just so on the cutting edge of everything, of course, including the topic today, which is the landscape of large language models. All right, knowledgeable. I know I can't English. Louis must be your theme song. Yeah, actually, I did ask you. I was like, how do you guys not confuse each other? And you're like, you just refer. He's Louis, and it's Louis Francois, right? That's how you
We
not
do
confuse
maybe
each
need
other.
to work on an AI-generated theme song on those lines. We can look at it.
Louis.
Thanks for the intro anyway, Tina. It's great to join everyone today.
Yes, thank you so much for being here. Who is he? I just explained who he is, so hopefully you heard that. Good morning from Bali, Dallas, Texas, KY is Kentucky. I got that right. Good job, Tina. Boca Raton, Florida, Owensboro Barbecue. I've never heard of that before. Hello from London, UK. Okay. Hi from. Oh, isn't it really early in London right now?
Yeah,
It
it
should be
must be
really
more very
early.
late, maybe more like midnight.
Okay, we're really late. Yes. Well, thank you so much for joining. Are you going to upload the stream after? I'm busy at the moment. Yep. So stream is going to be here. Oh, and let me send you guys the link. As per usual, please do sign up. The stream itself will be here, and do sign up here as well because I'll email you the slides that we're going to be going through today if you sign up in this link over here. Hey, Tina and Louis from Chicago. Volume is a bit low on the right. Who's that? Are you saying my volume is low or is Louis' volume is low? Hi from Hong Kong. Hey, we're in the same city. We're the same. Yeah. Hey, how are you doing? I'm in Hong Kong right now as well. Good morning from Singapore. Hello. Also a neighboring location. All right, I am going to let's get started because we do have lots of things to cover today, and I want to give you guys the opportunity to ask Louis all the questions that you want to be asking because he's such a valuable, like just getting him here, you guys being able to ask him, it's gonna, trust me, you will learn a lot from this. All right. So with that introduction, I already mentioned Towards AI. So at Towards AI, if Louis, if you want to just take over the slides, and then you can just let me know
Yeah,
when I
sure. I think
transition.
there's a little pop-up there. So yeah, I'll talk more about what we do at Towards AI later, but I'm CEO and co-founder of a AI education company, essentially. Been going for around 6 years now, towards 500,000 people in one way or the other through tutorials or live sessions or full courses. I think we can jump onto the next slide and get into the conversation for today now though. So, well, while also teaching AI with my own company, I'm also a large language model power user myself, both for work and personal tasks. And I now use LLMs, I'd say 20 to 30 times every day, using 5 to 6 different models for different tasks, huge range of different things. It's increased a huge amount in just 6 months, the amount I use it, particularly with new reasoning models coming out, new agents coming out, new capabilities unlocked. But what's holding other people back from my level of adoption? I think there's around 400 million people who now use ChatGPT every week, but only 16 million people actually pay for it with their subscriptions. And the free tier isn't really safe for company work, partly because the free models are less capable and reliable, but also the data privacy isn't strong enough for uploading company and proprietary data or expertise. So it kind of suggests there's not so many people that use it really regularly for work. Some people also use Claude and Gemini, Llama, DeepSeek, and others, but
Wait,
I
Louis,
guess less than a
sorry
million.
to
Yeah, carry on.
interrupt you. I know you're not using an external mic right now, so I lowered my mic volume a little bit so people can boost it up. But do you mind maybe just, if there's any way possible, just speaking louder or just being a little bit
Should I maybe
closer?
put my headphones in and get my Apple AirPods? It might help. I'll try it.
So we can't do that on Riverside. You
Yeah, I'll
can't do
just speak
that.
a bit louder, perhaps.
Yeah, yeah. I think if you could, I lowered, yeah, that works for me. So it's fine. I just lowered my volume a little bit. I will, and then if you could just maybe just speak a little bit louder, I think it should be fine. So people can just turn the
Put the
volume up overall.
switch up a little bit. That makes
Okay,
sense.
cool. All right. Thank you so much. Sorry about that.
No,
Sorry to
it's good.
interrupt.
So yeah, well, I guess that overall, there's probably less than a million people globally that use AI as much as I do today. But why is that exactly? I think cost matters for some people and for some tasks, but there are three bigger blockers overall. And the first one is just imagination and intuition. It's the question of how can LLMs actually aid your own work tasks? You can see cool examples online, but not really feel how you can adapt it yourself. You need to learn to think AI first and always consider how AI may be able to help in every task you perform. You need to experiment regularly and gain an intuition for where it helps and where it fails. And overall, it becomes more natural to yeah, work out how you can use it for more and more things. But the second issue is just education. You need to learn to use AI appropriately, else you get pretty bad results and you probably give up on it quite quickly. You must give it context and expertise and not expect it to know everything. You really need to kind of put all of your own skills into the model and not just rely on it doing everything itself. You need to put time and thought into using it and give clear instructions. You need to pick the best model for the task at hand, which is what we're going to talk most about today. You need to understand AI's weaknesses and check and edit all its outputs. So the third issue really is model capability and reliability is still lacking for many tasks. Even if AI saves time overall, people can still find checking mistakes too tedious. Um, I'll add on top of this, people are often just resistant to adapting their workflows and don't really have an urgency to make their work more efficient. Part of these problems can be solved with better models and better capabilities, and we're getting new models every week. But part is also solved by LLM developers building on top of current models. They make custom solutions to make better reliability on specific tasks, and this is mostly what we teach at Towards AI. But a big part is also just choosing the best model for your task, and yeah, this is what we're talking about in the conversation today. So I think we can jump on to the next slide, Tina.
Yep. So a couple comments. So Jane is saying security is an issue, so can't use public LMs at work, and the work version is still not up to snuff. And Rostam says lack of knowledge of which model is best suited to the task, and that is something that we'll be able to solve. And Jane as well. I think that's one of those things that it makes a lot of sense. That people have different versions, and I think learning about different LM models and how it is that you can be using them. Like for example, there's open source models and things like that, which could be used if security is an issue for you, which we'll also be talking about today. And from Ralph, ChatGPT blows away Gemini for Java. I think depending on what it is. Well, actually, that's a great question. That's a debate we can have in a bit as well. And Mahmoud, how to keep myself balanced when using LLMs to not make fully depending on this and how to track my usage. Is there a test that I could take each day to not kill creativity? I have to like
It's
read
an
this
interesting
question again.
question to think about.
Wait, sorry, what did you say? It's an interesting question.
Isn't it? Yeah, I'll have to think about a response to that, to be honest.
Yeah, we'll
I was
get
just
back to you
thinking
on that one.
on the security question, and like the free versions. I guess the main issue is the free versions of these chatbots. Generally, they allow the companies to train on your data you put in. So anything you upload or type can be used, and generally your companies aren't going to be happy with that if suddenly the next model knows some of like their internal private data. The paid plans nearly always commit to not training on your data and have policies you can select to kind of keep everything private. So really paid plans are normally safe, but there's huge amounts of different levels of security you can choose. You can deploy your own models yourself as a company and have the most like security, or you can have higher tiers of paid usage. I think one of the biggest risks with companies though is having zero AI policy at all, and then employees are using AI without training. They're using the free models. Whereas if they actually gave everyone access to paid plans, then they'd use both better models and also like have the higher security standards.
Awesome. Thank you so much for that. Next slide here. All right. Why is it getting so hard to choose the best LLMs?
So I guess choosing the best LLM is important, both for non-technical users, if you're using ChatGPT, or for LLM developers who are building custom AI apps. But new models are coming out every single day, and new capabilities are coming, new prices. So choosing the best LLM for your task is harder than ever. And I guess with my background, some time in finance, I often give a kind of finance or economics perspective on developments in AI, and that also comes in to the topic today. So we're discussing LLM competition and how it's driving rapid AI progress in two opposite directions with the latest models. And it's partly these kind of dynamics and economics that are making model choice even harder. There's kind of a divergence in what different companies are building. We're recently seeing much more expensive models that cost much more to train and use, and these are delivering extra reliability and new capabilities. And this is very clear with OpenAI's launch of its most expensive ever model last week and its API for developers. And O1 Pro costs 10 times more than its O1 model and 1,000 times more than its cheapest 4.0 mini model on a like, per word or token basis. The total cost for answering questions with this model could actually stretch to 5,000 or 10,000 times more than 4.0 mini. And we'll come back to what drives the costs of O1 Pro a bit more later. You can see in the image on the right here just the huge variation in prices for OpenAI models now. So it's obviously confusing which one you should actually use and whether you should spend 1,000 times more or not. As a non-developer, you can't see the model pricing as directly, but you can see these trends also in the rate limits of certain models in ChatGPT subscriptions. So some subscriptions don't give you access to the biggest models or very low limits. OpenAI has free plans. It's got $20 per month subscription, a $200 plan now. It's also launching a $2,000 per month agent plan later this year. So yeah, there's lots of choice of how much you spend, both as a developer or just a like non-technical user. But at the same time as these much more expensive models coming out quite recently, for the last few years, we've also seen a trend to cheaper models, and we're getting new breakthroughs which are allowing models to be created and trained and run and inferenced much more cheaply. So we've recently seen much cheaper models from DeepSeek in China and Google Gemini Flash, which are hundreds of times cheaper to run than the original GPT-4 cost. And they also have more capabilities than the initial GPT-4 did. So it's confusing because we're paying up more and more for the very, very best models, but at the same time, some great models are getting extremely cheap now. So there's these two opposite trends, and they have a big impact for AI competition, for adoption, and like overall accessibility for the models. And it's hard to say still which direction is dominating really. So I guess if there's more questions, we can take some else, jump to the next slide again.
Yep. So it looks like a lot of the questions that people are talking about here is just talking about specific models to use. So actually, this is a great question. I answered this in the chat already, but I would like to obviously get your answer as well. What do you think is if there's going to be one LM that you're going to choose that's the most beginner friendly? Do you have a specific answer that you would say for that?
It's difficult, to be honest. I think maybe 4.0 had a big upgrade this week. It'd been falling behind some of the other sort of cheap and easy to use models the last few months, but it's got big upgrades in kind of its coding ability, its general like instruction following, and also image generation now. So I'd say it had been moving away from 4.0 because it was falling behind. Now I'd say 4.0 is probably like an all-rounder which can do bits of most things pretty well. And obviously ChatGPT is quite well known and easy to use.
Yep, and I that's exactly what I said as well. And like ChatGPT, I think is the most user friendly to get into, and I would arguably say even if you're a developer and you're developing, I feel like OpenAI's ecosystem is one of the easiest to adopt, at least from my
I think so
experience.
too.
You would agree? Yeah.
I'd
Cool.
say Google has been lagging behind on making their models easy to access. They've got these confusing platforms, AI Studio, their Gemini chatbot, they've got Vertex, and they're not super user friendly. But AI Studio is actually very good for even non-technical people. It's mainly built for developers, but via that you can get free access to lots of the latest models and some quite kind of smart ones. So I'd recommend checking AI Studio out now as well to kind of play with the latest models they've released.
Oh, I agree. Yeah, Google AI Studio is great, and it's free for. But yeah, it's. I feel like it's actually really crazy how they allow you to use so many of these things for free and for a really long period of time as well. I think it
Yeah.
actually might be perpetually free, right? Unless you're trying to like go and actually call the I think it.
Yeah, if there's rate limits on the free version, and as soon as you kind of upgrade to sort of more commercial use, you start paying. But there's very generous free limits, so a lot of people can just stick to the free plan.
Okay, so there's a bunch of questions about what about open source models, which ones to choose. Do we want to answer these questions now, or I know we're going to be addressing the different models in a bit. So shall we do that
Yeah,
now,
maybe
or do
we
you want?
jump onto the next slide where I talk at a high level about some of them, and then later on in the presentation, I talk a bit more about like my top like specific picks on models.
Cool, sounds good.
So yeah, essentially, LLM competition is important because no one wants an AI monopoly. We want we want competition on pricing. So these aren't super expensive. These companies aren't making 80 or 90% margins. We want continued pressure on the companies to give people access to develop on top of the best models. The issue is if the best models cost tens of billions or even trillions eventually to train, we'll probably end up with a monopoly. Whereas if winning models can be trained for just millions of dollars, we'll see a lot more competition. I, After ChatGPT was released, OpenAI kind of had a monopoly for some time. It took a lot of time for anyone to release a model that could match them, both GPT 3.5 and then GPT 4. But it's changed a lot now, and there's a lot of companies that are competing with like really good models. In the US, the leading models are now from OpenAI, Google DeepMind, Elon's XAI, Anthropic, and Meta's Llama family. The Llama models are open source, which is yeah, very useful. Google also has some open source ones. The other ones I mentioned don't really play with open source models. In China, it's generally more open source friendly, where they give people access to download the models and more flexibility to kind of use them as they wish. In China, Alibaba's Qwen, Baidu's Ernie, and DeepSeek's models are the leaders, really. But across the world, there's also Mistral, Cohere, Microsoft, Amazon, Tencent, and ByteDance, which are investing lots to compete. Apple's also trying, but pretty far behind currently. But generally, the price of competing and building your own LLMs is not cheap at all. OpenAI is in talks to raise 40 billion now in an equity raise led by SoftBank in Japan, and they've already raised around 20 billion in the past. Elon Musk's XAI raised 12 billion last year, and it's now in talks to raise another 10 billion. Many large tech companies like Microsoft, Google, and Amazon are each investing 50 billion plus per year in building AI data centers. A lot of these investments are in training models on really huge clusters of tens or hundreds of thousands of GPUs. Some of the investments are just in clusters to run these models for users. That's called inference, serving ChatGPT and things to users. But despite these huge investments from lots of people, one of the biggest recent changes in the industry has actually been a reduced cost to train great models. And DeepSeek made lots of major contributions to AI research last year. They gave lots of breakthroughs available for free in open source papers and code, but it still surprised a lot of people when they released a very competitive model in December, despite a much lower budget than the US AI labs. DeepSeek's final training run for its V3 model cost just 6 million. I'm sure everyone saw it covered in the papers. To be clear, DeepSeek still also pay hundreds of top-tier AI researcher salaries, so they benefit from having like superstars on their team. And they also spend a lot of money on researching models like earlier versions and not the final training run. But still, the cost of DeepSeek's models raised the question for a lot of people: why are US tech companies spending billions of dollars on training these models, and do they really need to raise 40 billion this year? So again, we can jump to the next slide or take some questions here.
Oh, yeah, we do have quite a lot of questions. Let me
I think
just
also, Tina, that video you can maybe jump up on Twitter or something. It just shows just how dynamic the state of competition is with different companies taking the lead from each other this year.
Yep, here's the animation. Yeah, it's pretty crazy. Like this landscape, it just changes so quickly. Cool. Okay. I'm gonna go back to the slides. Oh wait, were you guys able to see that at all or no? Oh shoot, I thought I was showing it. I guess I wasn't. Let me. Is it showing it now? Okay, cool. Yeah,
Yes,
so
yeah.
you should be able to see that.
I'll talk a bit more later about what this is actually measuring, this arena for comparing models' performance. But it's just showing really just how rapidly the top model is changing this year.
All right, I'm gonna switch back to the slides, and we do have quite a lot of questions, which we can answer. All right, okay. So first comment is that DeepSeek is cheap. So this is more of a statement. I put $10 in an account in January, use it almost every day, and as of yesterday, I still have $9.97 in the account. I used 3 cents in 3 months. You know, okay, here's my general comment. I do feel like when it comes to a lot of the LM costs, and Louis, please like feel free to like correct me if I'm wrong. I think if you're not a developer and you're not using it in development, it is actually quite negligible in terms of how much things cost, like the actual model itself.
Yeah, for a lot of tasks, it's kind of very cheap compared to like human tasks already. And then paying for like the super expensive ones don't make such a difference on a lot of things. And DeepSeek, yeah, is great. The price is there. Gemini Flash 2.0 is also super cheap. They're probably the best two in terms of cost. Also, as I mentioned, Google makes a lot of them free on like a smaller basis as well.
So from Jordan, please distinguish between open source and open weight. People need to know this.
Yeah, it's definitely important, and there's really very few properly open source AI companies anymore. There's a few labs out there. Open source would really mean these companies fully were transparent about what their training data involved. They perhaps even upload the full training data so other people can recreate the model. They give all of their code on how they trained the model, every step of it. Open weight just means the company releases the model weights for free download, and then from there people can do what they want with it, but they still don't really know exactly how it was created and they can't recreate it themselves. So um, fully open source is the best if people were willing to give away all of their like training data and things. Most of them are instead just giving away their final model, like Meta with its Llama models, DeepSeek with its models, Alibaba's models, there's a few others, Mistral offer lots of open source, open weights models. But yeah, there's not really a super competitive one which is fully open source. Some companies give more detail than others about how they built the model and give away more open source repos and things, but none of these leading ones I mentioned actually give everything to kind of classify it as fully open source model.
From Lance, what is your opinion on Mistral and its capability? Is EU far behind?
Mistral is kind of getting a bit of a niche for some uses. The thing we're using it for is optical character recognition. So it's sort of they've got a really good model for processing PDFs or other files with their LLM and just kind of structuring it well into a database. They were kind of the leading in open source for a while. They fell a bit behind um, DeepSeek and Llama in adoption and kind of the performance of their open source. And now some of Mistral's best models aren't open source either. They're just available via chatbot or API, but they still got some great ones. It's just some more niche uses that we're using them for rather than kind of everyday things.
Would you say that EU in general? Do you have what are your thoughts about
Yeah, I
Europe?
think EU's generally a bit behind, partly because they're not getting enough, as much funding as companies in the US, and then there's competition from the big tech companies to hire the best researchers. So it's harder for like European startups to get as many kind of superstar researchers on the team. That said, a lot of Google DeepMind is based in London, so even though it's a US company, there's a huge, like, strong set of AI talent in Europe, and that spreads to like Paris and other places in Europe too. It's just the companies aren't quite as well funded.
Cool. Let's see some other specific questions. What do you think about the ethics behind the companies that build these models? I would not be a supporter of anything Elon builds right now. Do you, yeah, do you want to take this question,
Yeah,
or it's not?
it's
It's
kind of
not super. Yeah, please.
there's lots of complexity in like the ethics of AI, like from is it ethical to take data from the internet and train models and profit from it in the first place, and then like the specific actions of the CEOs or kind of philosophies of the companies varies a lot. So yeah, some of that can lead you to choosing some models over others. I don't really see a huge difference in how they actually are to interact with, though, between the different companies currently. I think some companies have less filters on what the models are allowed to do than others, which means that they may be able to be misused more than others. And for some, that might be kind of a political decision. But yeah, it's a tricky topic.
Yeah, I was gonna say it can be a touchy topic. So a couple questions here. Journey with Rain Quinn, should you use a VPN when using an AI? The reason why I was talking about using VPNs previously is just because in some places it's not available. Like in Hong Kong right now, you actually ChatGPT OpenAI is blocked. What else is blocked? So Gemini is blocked. So Google AI Studio is blocked, and also Claude is blocked as well. So I use a VPN, and other people in Hong Kong, other places use it as well, mostly just to get around that part of things. Of course, yeah, you can use a VPN if you want. I don't think it honestly makes, if you don't need to, I don't really think it makes that big of a difference. And another comment, Open WebView is open source and it has super nice features that optimize how much has to be resubmitted in each request. And from Richard, anyone who thinks China won't end up dominating is wrong. China has the biggest economy and the largest population of educated people. They can't fail to dominate. No comment about that. No, I'm kidding. There's actually, okay, so I was like, oh, I'm like, should I say this? This is slightly politically incorrect, but I'm gonna say it. All right, guys, are you ready? Don't don't quote me on this one, okay? Nobody quote me on this one. I heard about this running joke and I thought it was really funny. So people were saying that right now the competition is between the Chinese people in the US versus the Chinese people in China. Like it's like literally you see like Madness comes up as like a Chinese person in China, DeepSeek is like Chinese people in China, and then the other things that are being released, you'll notice that there's a lot of Chinese people in the US. So that's kind of like a thing that people are saying right now, and in Silicon Valley as well. Like a lot of the basic research, a lot of things that are being done in universities and stuff. A lot of people are, yeah, like overseas, like Chinese people, like ethnically Chinese. Yeah, and I think it's just, I thought that was pretty funny when somebody said that.
On the US versus China angle, I think that comes into play with the next slide and the next topic a bit. But China's got a huge amount of great researchers. It's very well organized, obviously, economy. It's got lots of access to power and things and to kind of organize people to solve this problem. The one thing that it struggles with currently is access to the best GPUs from NVIDIA. And the US has kind of been progressively stepping up sanctions that are preventing the best chips from being allowed to be sold to China. So that's one of the key questions for China is, do you need like tens or hundreds of billions of dollars of chips, which NVIDIA is no longer allowed to sell into the country, or can DeepSeek keep kind of innovating with much less chips? Obviously, some Chinese companies are making great chips themselves now, but they generally still use chip manufacturing equipment from ASML in Holland. So they're sort of quite exposed still to like sanctions from US and Europe if they really want to cut out access to the best AI training chips.
Yeah, I was actually at a talk yesterday, sorry, 2 days ago at night, and we were talking about Chinese AI versus like kind of Western North America usually like AI. And Hong Kong is actually a great place. Yes, I am in Hong Kong right now because you actually get that influence from China and you also get a lot of exposure from the West as well. So we were talking about this topic. And I think the way that people like to put it, 0 to 1 innovation, I think is still very dominated by the Western world. It's like the US is, innovation wise, 0 to 1 development. It's always been like that for a significant period of time now. And what China is really good at is from like the zero point 0.7, or like 0.5 to like 1.5 upwards. So they're really good at figuring out things to do on top of that initial innovation to bring it to consumers to lower costs and things like that. And we've seen that trend many times now, right? Like including things like electric vehicles and stuff. Like initial innovation happened in the West, but what China's really good at is actually lowering costs down, coming up with like little tweaks and like coming up with not little tweaks, but like significant advances to actually bring it to consumers and make it viable. So I do feel like, at least from that angle, that is really where a lot of like Chinese innovation shines. Okay, not to get too much into politics, let us move on to the next slide. All right.
So to come back to like how many GPUs do we really need to train the best models, and does China need access to NVIDIA's ones or not? It makes sense to take a step back first and explain scaling laws for AI. So a few years ago, researchers discovered that when you train LLMs, if you increase the amount of training compute used, it results in predictable improvements in performance and better test scores for these models. So if you think of training compute as a number of GPUs working together for months at a time to create these models, more training compute just equals more AI capability. And you can scale the compute either by increasing the training dataset size, which is already tens of trillions of words or images, or by increasing the number of parameters in the model, and these are also now in the trillions. If we double either the number of tokens or the number of parameters, we double the training compute. If we double both at the same time, training compute goes up 4 times. If you look at the graphs here, the technical details aren't really important, but the key thing is the chart on the left here is showing on the y-axis a measure of error rate of the model. It's going down as you scale the training compute used on the x-axis up over 100,000 times. So these are different versions of Meta's Llama model, all using the same training recipe. It's just you put more computing into it, and they could predict over this massive scale exactly how well it would improve. And this is great for AI research costs because you can experiment with smaller, cheaper models and then predict how they'll perform if you scale up 1,000 or 10,000 times and put like your biggest training clusters to training it. It's also great for AI companies to plan ahead and promise investors future capabilities when they are raising money to build these larger GPU clusters. OpenAI defines a generation of its models like GPT-3 to GPT-4 jump as about 100 times more training compute. So these are really huge steps up every time in scale. But the catch with scaling laws is that it's a power law and it gives you diminishing returns as you progress. So even though you can see this on the chart on the right here, it's kind of an S-shaped curve. As you get better, you get kind of saturating the benchmark, you get less progress for the same amount of for the next 10x in compute as you did before. So it gets very expensive very fast when these models can already cost towards $1 billion to train. But fortunately, scaling training compute and GPU numbers isn't the only way to improve model intelligence. Because of the diminishing returns you do get from scaling, you don't want to only scale the same training recipe when you build your next model. You want to add lots of other improvements on top of this. So we can jump into what these are on the next slide again, I think.
Next slide.
So separate to the just spending more and more money, one key way to get better models is better pre-training data. So this can be higher quality because you filtered spam out of the internet, or it could be because you've created synthetic data with AI models which have like extra information that the general internet didn't have. Another step is just efficiency of the algorithm you're training with. DeepSeek, for example, used a new mixture of experts design and several other changes to make it a lot less expensive to train models. Then there's also post-training. In pre-training, you're training a model to predict the next word in its data set. In post-training, it's a bit more targeted training and feedback where you're really trying to make them follow user instructions and give responses that humans like. And there's lots of techniques here. Some of them offer major gains. Some come with large compute requirements, some almost none. A newer method, which it was introduced with OpenAI's O1 model in September, is reasoning models, and this is inference time scaling. This means the number of words or tokens used by the model during the response generation in the end product, like ChatGPT, and not what's used during training. Another powerful approach to improve model intelligence is building custom LLM pipelines on top of foundation models. So that's what we focus on at Towards AI. And developing on top of these foundation models, it can have huge improvements in capability and reliability on specific tasks without adding a huge amount more cost. And yeah, the main aim of all of these is to boost both performance and reliability on targeted tasks. So I guess we can take more questions here or jump again to the next one.
All right, some questions here. The next type of model will be LEM, large energy models. They will give the ability to actually make real decisions based on least energy used. Any comments about that?
Yeah, it makes sense. I maybe have read the acronym, but definitely models which for themselves can dynamically choose how much kind of compute intelligence they need to deploy to different problems is going to be super valuable. It takes some of the complexity out of choosing yourself, but there's still going to be lots of variation in different model platforms to use. GPT-5 is rumored to be sort of one of these models which kind of interprets the user's response and then routes it to many different models to answer it depending on what's used. And a lot of that is both to optimize energy used and also just the cost of the models. So yeah, I agree that it's going to be important.
From Richard, large diffusion models are a new thing. They generate output all at once. not a character at a time. Weird but interesting. They work faster.
Yeah, they're really cool. There's two recent, like quite significant new architecture changes in LLMs, which people have been scaling recently. One of them is these diffusion models. Diffusion was normally used for image generation, and now people are first getting it to work at some scale on large language models. There's also some competition in the other direction, though, whereas yeah, LLMs use this autoregressive transformer model where it generates output one word at a time, whereas diffusion generates the whole thing at once, but kind of gradually reducing the noise and making it hone in on the correct output. But yeah, transformers like GPT-4o are actually stepping on the turf of image generation diffusion models now, and ChatGPT can generate images itself directly with a transformer rather than diffusion. So each kind of method of AI is competing with each other now. I think there'll probably be benefits of both, kind of different strengths and weaknesses.
Let's see a few other questions. Um, from Jane, Louis, speaking of AI capabilities, do you have any opinions about when we will see AGI?
It's super hard to pin down, to be honest. One of the hardest things is just the definition of AGI in the first place, because a looser definition of AGI, just where it can kind of do all useful tasks humans can, but potentially using 10,000 different models which have been customized by different developers, kind of each kind of targeting every subtask that humans work on. That's a lot more achievable than a single smart model that can do everything kind of automatically with no like human expertise going into designing like specific workflows. So I don't know, it could be anything from 2 to 10 years, but really it's moving so quickly and so many unknowns in terms of what roadblocks will hit and exactly how you define it that it's difficult.
You also get Andrew Nate, who claims that we've already hit AGI because in his definition, it's already able to do general things. So I think it's the definition of itself is such a moving goalpost, I think.
Yeah.
Um, let's see. In LLMs, do they ever use a GPU-based database to serve the dataset?
Um, there's data stored very close to the GPUs. There's some kind of on the same chip, essentially in high bandwidth memory. There's some stored like just very close to it on like slightly less fast memory. But generally, yeah, companies try to keep data quite close to the models. But there's various different types of memory that these models can access.
All right. I cannot read Korean. Sorry about that. Okay, let's take one more question before moving on. So we still have some other slides as well. So from Christopher, are we relying too much on benchmark LLMs, are trained to beat and overlooking models that would be better for specific real world use cases?
Yeah, I definitely agree on that. I'm going to cover a bit of benchmarks later. Benchmarks are definitely flawed, and really you need to test it yourself on exactly what you're using it for to see how it performs. If you're an LLM developer, you need to build your own kind of evaluations which are really tailored to the real world problems you're trying to solve. Generic benchmarks can be super useful, but yeah, it's very hard to kind of test the nuances of what you're using these things for in the real world.
Cool. Yeah, and I do feel like it seems like 5 and 6, especially 5, what you guys are working on for towards in towards AI, is where you can start customizing a lot of things. It seems like from 1 to 4, these are things that if you're building models, or if you're working towards building your own models, which most people are not going to be doing, that's what
Yeah.
they're looking into. But 5 and 6, you have a lot of control over.
Yeah, 1 to 4, you really need to be working at one of like the 10 leading AI companies to make much difference. But 5 to 6, almost anyone can get involved now. Even non-developers can quite quickly pick up enough development skill to start customizing these things, or even just teaching people, colleagues, friends how to use them.
All right, next slide.
So yeah, all of these factors of improving models, what does it mean for AI competition? Will the market consolidate around 1 or 2 labs that just keep chasing scaling lords and end up spending trillions of dollars on models? Or will focus shift to cheaper routes that allow for dozens or hundreds of strong competitors? some performance gains still require massive capital. Some need AI superstars to like have a breakthrough idea. Um, but some can be achieved quite cheaply, like building custom LLM pipelines, like I mentioned. They don't need much capital. Thanks to sort of all these methods, and improvements in GPUs as well from NVIDIA, creating a model like GPT-4 now costs 20 to 40 times cheaper than it cost 3 years ago. So it's kind of getting more accessible to make strong models. But does that mean we no longer need bigger models at all? I don't think so, really. And the reason is all of these different angles for improving intelligence stacked together. So you can scale compute and improve data and make better architectures and scale inference. And they have different types of new capabilities or different types of intelligence they unlock. So if you stack them all together, you're still likely to get the very, very best. So scaling compute is additive to different types of AI progress. I still think we'll see these 10 billion plus models being trained. OpenAI is in fact planning to increase its training compute clusters 8 times in size just this year, even after like DeepSeek's innovations. But in many cases, cheaper models now yield bigger capability gains much more efficiently. So sometimes these $10 billion models will underperform a new $10 or $20 million model. So it's all confusing. Any CEO who's really chasing AGI will still want to have the largest training cluster. It will allow them to have the biggest model, to train models faster and to iterate on them faster also. But it's only one piece of the puzzle really, and it should only be one part of the gains they plan for in a new model generation. And the recent breakthrough with reasoning models is a great example here. These methods delivered really big gains really easily compared to scaling to bigger models. So reasoning models without huge amount of compute outperformed GPT 4.5, which had 10 times more compute on a lot of things. In overall reasoning breakthrough, which was like an AI superstar idea, it skipped us perhaps a full GPT generation ahead. So maybe equivalent of 10 or 100 times more training compute used is the gains we got out of this. And these breakthroughs enabled companies like DeepSeek to achieve cheaper, more capable models on quite a low budget. But these reasoning models also have unlocked new ways to scale. Before, we were running out of high quality internet data to train models on. So there's kind of this dead end, and how do we keep making models bigger if we don't have more data to train them on? Now with reasoning models, you can potentially make unlimited reasoning data synthetically, just having AI create really long solutions to problems that it creates itself. So the balance is hard to pin down here, but fortunately, as a AI user or an LLM developer, you don't need to train these models yourself. You can access them via chatbots, build on them via APIs, or download the model weights. So the current competitive situation is actually great, really. Open or closed models, they both give access to like the very smartest models almost immediately. You can customize them via fine tuning, build on top of them. So we want it to stay like this. Ideally, things will get even more open, but yeah, we don't want it to consolidate into just OpenAI with $1 trillion company no longer giving us access to things.
I'm glad to hear that. I'm actually really glad to hear that. I think that's something that a lot of people are quite worried about. So it's really good to get your input about it, right? It's like because there's just so many things that are happening, and people are really worried about just conglomerate of power that all of these AI big tech companies are going to have.
Yeah, I think so. Should we jump on to the next one?
Yep, next slide.
So yeah, the end result of all of these things is we'll have a wide range of models from different companies, and more price competition is good for LLM users and developers, but more model families and models also makes the choice much harder of which do you actually use. The key for both developers and AI users is to build an intuition for the strengths of each model and then pick the best one for every job you're doing. Often the best results will come from combining multiple different models, and some open, some closed, within like a pipeline. Towards AI, we often have 2 to 3 different models from different companies in the LLM projects we build. It's also important to make your LLM pipeline portable so that you can easily switch to a new model if needed. And it means you need to build robust evaluation methods to detect performance changes. You don't want to have a new bug suddenly appear in your product just after you upgraded to what should be a smarter model. So right now, OpenAI leads on reasoning complexity. Anthropic's Claude is great at writing working code straight away. Gemini Flash and DeepSeek are best at inference cost efficiency. Open source models are easiest to adapt and deploy yourself. We'll talk more about our favorite models, though, in a later slide. So I guess we can move on for now.
All right. Oh, so we do have a specific question on Gemini 2.5 Pro. Yeah, 2.5. I think we can answer this one. With Gemini 2.5 and similar capabilities, can we dispense with RAG for simpler use cases, making for great cost efficiencies?
So you can, RAG is where you feed lots of data into a model to answer like specific questions. So it has the knowledge it needs to answer, but often your data set is huge. So you need to select what the actual useful documents or paragraphs or text are within that before you feed it to the model. And really long context models allow you to feed in a lot of data, but some of them can have 2 million tokens or words in context, but often their performance still drops off after 10,000 or 20,000 words. So RAG, where you're picking from maybe 10 million or 100 million or even a trillion like words in your data set and putting in the most relevant information to the model, it can still make it a lot cheaper and faster and sometimes better results. But now the lines are blurring more, and when we build RAG, we put a lot more data into context using Gemini than we used to. So we might feed in much bigger chunks of documents and many more results than before.
All right, next slide.
So yeah, choosing your models is difficult, and there's lots of things to look at when choosing. One of the first steps is just critical functionality for your task. Like, do you need image understanding or image generation or audio generation? Not all models offer all of this still. Context length, which we just mentioned, is also important. Gemini is great here. Some others have long context. Smaller ones can be difficult for some tasks. Knowledge training date and knowledge cutoff is important. So if the model was trained 2 years ago, it might not know the latest terminology or latest events, and for some things that's very useful. So Gemini Pro 2.5 is the most up-to-date model. It was trained in January, so it knows things like US elections or the latest AI development techniques from last year. Beyond these kind of core features of the models, we also need to evaluate the capabilities more robustly, and this is about benchmarks, which we talked about briefly. The problem is it's hard to create tests for real-world uses, and models sometimes also come across answers to these questions in their training data, so it can leak a little bit. They're not always the best tool, but they're the best we have really for comparing models at large scale. One issue is there's hundreds of benchmarks out there now, so you need to find the most relevant test for your own task. You can also filter the test scores by subcategories. So some of the benchmarks might say, I mainly want to look at its score on maths questions or on writing questions, and that's useful to look at. LiveBench is a really good one. It runs regular tests on all the latest models. It has fresh questions it creates, so they're not leaked in training. And it's got various different categories like coding or reasoning. MMLU Pro is a good one for general capability and knowledge. I'll send out a spreadsheet actually I'm working on in the next couple of weeks in my newsletter, which links to all the current leading benchmarks, including ones which are like creative writing focus, summarizations, and data analysis. If you're developing LLM pipelines yourself, it's also important to build your own custom evaluations, though. You need to really tailor it to your specific use case. Think of the problems you're trying to solve, what errors could come up, and build something yourself. This can be one of the kind of key bits of IP in your product if you're building an LLM app, actually thinking really carefully about your evaluations. Separate to benchmarks, leaderboards and arenas like LLM Arena, which was the chart we showed the visualization from before, and artificial analysis also run arenas. These are good because they put two answers from two different models up against each other and get users to choose their favorite. So this is testing more real human preferences on kind of tasks that they actually use these models for. So benchmarks tell us more about how models perform technically. Leaderboards show us more about which ones people prefer using, but custom evaluations are what you really need for like real world tasks, for things you're using it for.
Awesome, thank you. So there are a couple comments over here. So fine-tuning open source LLMs like Gemma or DeepSeek, is this makes me able to share fine-tuned models as a service, or do I need permission from the LLM owner? You do not need permission. You can fine-tune it yourself, or do other things that you want as well. I actually had a question, Louis. So, as we're building, because within Lonely Octopus, where we teach people AI skills and we build different AI projects for different companies, right? So while we're doing this, I feel like there has been kind of shifts in terms of how it is that people are doing things. And because it overall, like you have the LLM, which is the core of whatever it is that you're building, your AI application, your AI agent or whatever, but you also layer on things like tools and memory, like whether that be static memory like knowledge, or whether that's dynamic memory. And there's also like a lot, orchestration, the actual like way that you're orchestrating the different LLM calls or different sub agents, if you like to call it, all of these like other factors that are coming into play. And of course, the actual prompting of the agent, or whatever it is you're building itself, the LM itself. How important do you think the model choice fundamentally is for what you're building?
I think yeah, it is very important. When you get more complex in these agent pipelines, you need to normally use two, three, maybe four different models. Some part of the agent might need really strong reasoning to really pick the best tools to break down a problem into like achievable subtasks. But using that smartest model for every step is way too slow and expensive. So you need to combine bits, figure out where in the process you need the most intelligence, the most reasoning, and then in other bits where you need it to be quick, cheap, fast. So I think it gets even more important as you build these more complex pipelines. Perplexity, for example, in its deep research agent, it uses GPT-4o, it uses an internal like fine-tuned llama model, it uses Sonnet 3.7, and it also uses one of the reasoning models, I think maybe OpenAI. So four different models in that agent. Um, so often you're going to combine lots of different ones from different companies, and it can make a big difference, particularly on like cost and latency of like your final result.
I see, I see. So if you're say we're just building like a smaller project or a demo of something, would you say it's reasonable to say you can get away with a lot of things? But when you start scaling it, wanting to have it in production, connecting with other software, and when it gets more complex, then it becomes a lot more important? Or do you think it's really important from the very beginning to think very carefully about the models that you're choosing for the application that you're building and how you're chaining together different models?
I think it definitely gets more important as you scale when costs become more important, and also when you're solving you're caring more about the smaller edge cases of like errors that might come up where maybe only one model can fix it. You need to kind of really finesse your choice more. It helps to start out with the best choice though, like more broadly the right type of model. But then as you get more into an advanced product, you need to much more kind of finesse the exact model in each category that you're using at which stage.
Got it. Got it. Cool. Yeah, I think I know on your newsletter you talk about these topics as well. Like maybe if you can point anybody to, or it's how it is that you can concretely actually figure out which models to choose. I think there's actually not great guidance for how to do that. At least like the way that we do it now, a lot of it is just trial and error experience and also just like working with different models. But I'm really curious to know, maybe you have a different yeah, actually how to choose LLM price and latency. So I think we're going to be going through some of that right now. All right.
Yeah, let's jump onto this one. So yeah, I talked more about like kind of the capability and core features of models before, but price and latency is also a key part of your decision. And the huge variations in pricing is making it even more confusing. On cost efficiency side, we've seen a clear trend of cheaper models for the last 3 years, but it only really hit like the mainstream news recently with DeepSeek. Um, DeepSeek and DeepMind are leading on like cost efficiency. Gemini Flash 2.0's input tokens are 600 times cheaper than GPT-4's were at launch just like 2 years ago, and the model is also more capable. So it's like ridiculously fast progress in cost reductions. And in general, cheaper models are also faster because they're smaller models. They need less compute. Um, and these gains in efficiency have come from multiple sources like better data curation, better model architectures, model distillation, improvements in GPUs used. So we're seeing rapid progress, not just in training smarter models with less compute, but also in serving models more efficiently in inference time. But how important is the race for like cheaper and cheaper models versus the race to develop cutting edge intelligence for things? I think most tech progress in other areas is measured mostly in cost reductions. In AI, we're spoiled by getting real capability gains at the same time. But if you think of all the hard work and inventions going into solar panel prices dropping 80% every 10 years, the actual capabilities haven't really changed. It's just the cost that all of this inventions are going into. And same for Moore's law for computer chips with transistor cost declines. The transistor does the same thing, really. It's just there are much more of them, they're much cheaper. LLM inference token costs on a comparable basis are actually dropping much faster than Moore's law did at its peak. And we think this will continue. Anthropic's CEO said a week or two ago that he expects about 4 times lower cost each year for models for the same level of intelligence. And this is from hardware like GPUs, from software, from better machine learning ideas. But despite all of this, AI models are already often thousands of times cheaper than humans cost per hour. And most often it's actually capability that holds back adoption rather than price. So often you will still find yourselves wanting to use the most expensive models because these are really at the frontier of like the new tasks you're now suddenly able to do. So intelligence and reliability of cheaper models is not always good enough for everyday use at work. Like 4.0 Mini might make too many mistakes. It might just not grasp like the understanding your prompt in enough detail. Cheaper models I find most useful are for high volume, simpler automated tasks, or as like sub-steps in a more complex LLM pipeline. So it could be extracting data at large scale for you and answering some questions. It could be like an intermediary step in an agent. They're really good for things like ingesting whole YouTube videos with Flash as well and analyzing films, but not so good for like writing tasks or day-to-day brainstorming at work. So I think we're going to get all these breakthroughs which make AI cheaper and cheaper, but I think this is just going to unlock better intelligence and people are going to keep the same budgets. They're not that likely to choose non-state-of-the-art models just to save money. Probably people will mostly be using ones which are kind of at the edge of the capabilities.
Awesome. Okay, so in the interest of time, do you think perhaps we can briefly cover these slides on inference? And so reasoning models, I think that one is really, really interesting. And we can go on to the Freire models. And I do want to leave enough time, just a little bit of time for you to talk a bit about towards AI. Would that be
Yeah,
okay? Just touch
I'll
on reasoning
run
models
through
and then,
these two real quick.
yeah.
So yeah, basically there's a few reasons why suddenly models are getting way more expensive, and this is mostly due to reasoning models. So reasoning models like O1 and O1 Pro were likely built using GPT-4o as a base model. They've already unlocked a lot of new capabilities and solved some complex benchmarks like some maths, coding, science tests. They jumped from 10 to 20% scores with 4o to now 70% plus area. And this is all because of the model spending time thinking and planning its answer before it actually generates its response to you. The issue is you can choose how much time you set it to thinking. You can make it think for 1,000 words, 10,000 words, 100,000 words before it answers you, and this will get better answers, more likely to be correct, but it's very expensive to scale costs like this. Separate, maybe we can jump to the next slide now, quick. But you can also scale models in parallel. So rather than just making it think for longer before it answers you, you can have 10 different models side by side trying the same answer, and then the best answer is picked and shown to you. And this is likely what O1 Pro does with OpenAI. And this is good because it, rather than you having to generate lots of responses yourself and pick the best one, it automatically does it for you. It's just, it adds huge costs very quickly. You can still scale models to larger and larger sizes, and this gets results too, like better capabilities. For example, 4.5, GPT 4.5 from OpenAI, it's 750 times more expensive than Flash 2.0. It's still a non-reasoning model. It unlocks some new things like general knowledge, humor, emotional nuance, but yeah, a huge cost. So there's all of these axes now to increase cost in return for getting more capabilities. But the question is really just how much compute is actually worth it for your task. Stacking all of these kind of improvements together, you can actually spend hundreds of thousands of times more with reasoning models than like the base model, just to answer the same question. But clearly, a lot of a task that becomes quickly unaffordable. We can jump on to the next slide again, where I'll talk a bit more about exactly which my favorite models are right now.
Yep. So I know we're for again, I just put the link over here. If you want to have these slides, please do sign up and we'll email you the slides afterwards as well so you can go into more detail. But yeah, let's move on to Towards AI's current favorite models.
So yeah, which model to use comes down to your use case and the price, really. Reasoning models are not always necessary. They're very heavily trained on code or maths problems is kind of the step which was used to make them smarter, but it can reduce their writing ability, some of their other creativity. So when accuracy or problem solving, maths or code really matters, reasoning models are definitely worth it. But there's lots of tasks where they're not worth the cost or even perform worse. Generally, you should invest more when the reliability you get back saves more of your own time or prevents more errors than the increased cost of the models. So my main tip is balance the value of your own time saved checking outputs versus the extra model cost. And sometimes O1 Pro generating 10 outputs, giving you the best one, it can really be worth it rather than you picking yourself. But all of this varies also depending on the value of your task, on your own salary. Obviously, higher value tasks, it's also more important you've got no mistakes. So I'll just run through quickly some of the models we're using at Towards AI most regularly, looking at reasoning models or reasoning modes of models. To begin with, O1 Pro, obviously the most expensive for complex reasoning tasks where you want high accuracy, the best results straight away. It's great. It's good for brainstorming or planning complex code projects. We've used it for lots of different things Towards AI. DeepSeek R1 is just a strong all-round reasoning model. It's affordable, it's versatile. It's surprisingly great for creative writing as well, against the trend of writing getting worse for these models. O3 Mini, it's from OpenAI also. It's best for like efficient science code questions where compute cost matters and you don't want to spend as much as O1 or O1 Pro. Claude 3.7 with thinking mode, it's great at code. It also gives good control on how many thinking tokens you want it to use. You can push it to really long outputs. Sorry, just checking a message. Yeah, then Alibaba's QWQ is if you're an LLM developer and you want to actually fine tune or adapt a reasoning model yourself, this is the best open source one. DeepSeek R1 is open source, but it's really complex to run it yourself. It's a complicated architecture. You need a lot of GPUs. Alibaba's one is a lot easier. So if you want to develop on top of a reasoning model, I'd currently use that one. Gemini Pro 2.5 just came out. It's really great all-round model. We started using it for complex RAG use cases, as we mentioned before, using more data in long context rather than as lots of retrieval steps. It's in experimental access, but it's got the most recent knowledge cutoff as well. So January this year is really useful. In terms of non-reasoning models, I use these for writing tasks, for simpler tasks with like less steps needed to follow, for ones where response speed or cost are more of an issue. GPT-4o is a great all-purpose workhorse. It got a really strong update this week. It's strong across tasks. It's got multimodal, so you can do audio in and output. It follows writing instructions as well. It just got a really great image generation ability this week, which I'm sure you've seen trending and played with. Gemini Flash 2.0 and DeepSeek V3 are the ones if you really want low cost. They're great for internal steps of LLM pipelines or automating data processing at scale. Flash has also got really good multimodal inputs. DeepSeek doesn't. Claude 3.7 is the best for generating working code in one go, so it's really good, both used in a coding agent model or for vibe coding, like using AI to make code as a non-coder. GPT 4.5 and Grok 3 are the largest general purpose models currently, so they're expensive, but you can use them for complex dialogue where you want high level of general knowledge, or ones where you want more emotional understanding or personality in the response. And then on open source, again, Llama and Quen from Alibaba, both their 70 billion parameter models, they're really great for fine-tuning internal deployments for companies. So they're great for LLM developers who want full control of adapting these models. These favorite models, they change every week, to be honest, but these are the ones we're using right now.
Cool. Thank you so much for that. Again, all of this is going to be emailed, so don't worry if you were not able to catch all the really great information that is happening in terms of how it is that you should be choosing models. So we are over time, and I did want to make sure that I can respect Louis' time and your times as well. So I just wanted to end on this slide. So Louis, please tell us a little bit more about Towards AI, where people can find you. I know you publish newsletters, you have great resources, and you also have Towards AI Academy.
Yeah, sure. So I guess we started out by discussing the challenges to everyone adopting LLMs, and even for me, lots needs to be fixed to use it on even more tasks. And that towards AI, we think we'll need millions of LLM developers building custom LLM pipelines and LLM agents for different tasks to really build products that are just a no-brainer for global adoption for everyone at all companies. And this customization work, it can lead to huge jumps in reliability and capability, even with today's models on particular tasks. So, but yeah, fully solving tasks with AI, it still needs a human touch at the moment. So LLM developers, they spend time crafting strings of carefully chosen prompts and models together with the most appropriate LLM techniques like curating datasets, retrieval augmented generation, evaluations, fine-tuning, tool use. They also integrate expertise from human experts, and they design the AI products to slot into people's workflows more intuitively, make it easier for people to spot hallucinations. And all of this is why at Towards AI, we've built the best, the most comprehensive advanced LLM developer course out there. And 90 lessons, many notebooks, and complex multi-stage core project. We teach everything from scraping and parsing your custom dataset to implementing all of the major LLM techniques. And for non-developers, we also offer a beginner Python course to first learn the key coding skills needed to then take our advanced LLM developer course and start building apps yourself. We teach this LLM natively, which basically means you use AI to generate code, iterate on code, you quiz it to teach you each line, each function it's using. All of these you can find on our Towards AI Academy course homepage, linked in the video, or the links in this slide. For 5 years, we've taught various AI courses, tutorials. We publish lots of blogs and articles every week. We've really focused in on large language models, though, in like this LLM developer skill set the last 2 or 3 years. I've also got a weekly newsletter where you can keep up to date with like an in-depth discussion from me on the biggest event or trend of the week, as well as links to all of our like new courses or free materials for people wanting to use these models or wanting to develop with them.
All right, thank you so much. Thank you so much, Louis. This was honestly very, very enlightening in terms of especially understanding now the importance of keeping up and understanding how to choose different LLM models. And for anybody that's looking to develop products, or anyone just looking to keep up with the industry overall as well. So thank you so much again for this. Everybody, please sign up for that link on Lonely Octopus workshops. We will email you these slides as well as additional resources and information, and you also get alerts for upcoming live streams as well. So please do that. Thank you so much, Louis, and thank you all so much for coming and joining this live stream, even though it's like 1 a.m. for some of you guys. So go to sleep if it's 1 a.m. for you, please. And I'll see you guys in the next video or live stream. All right. Thank you,
Thanks very
guys.
much, Tina. Thanks everyone for joining.
All right. That is done, and I can stop it here.